In 1943, Britain faced a crisis that threatened to lose the war before D-Day could be launched. German U-boats were sinking merchant ships faster than they could be replaced. Conventional anti-submarine aircraft dropped depth charges that submarines could evade, fired rockets that rarely hit, and carried machine guns that couldn't penetrate pressure hulls. Then Britain mounted a naval destroyer's gun, a 57mm cannon, on a wooden twin-engine fighter and created the deadliest submarine hunter ever built. The Mosquito FB Mk XVIII could kill a U-boat with a single burst from a weapon that shouldn't have been possible to fly. By early 1943, the Battle of the Atlantic had reached a critical phase. German U-boats operated in wolf packs that devastated Allied convoys, sinking over 500,000 tons of shipping monthly. The submarine's greatest vulnerability was transit through the Bay of Biscay between French bases and Atlantic hunting grounds, where they had to surface regularly to recharge batteries and run diesel engines, creating detection windows that Allied aircraft exploited, but existing weapons couldn't reliably kill submarines once detected because depth charges required precise positioning, and submarines could crash dive in 30 seconds. Coastal Command's anti-submarine arsenal was desperately inadequate. Aircraft dropped depth charges that had to land within 25 feet of a submarine to cause damage, difficult against moving targets with skilled commanders who maneuvered during attack runs. Rockets provided standoff capability but suffered from terrible accuracy, with hit rates below 5% even against surface submarines, and machine gun fire, even 50 caliber, couldn't penetrate pressure hulls, only killing exposed crew and damaging deck equipment while leaving submarines capable of diving and escaping once aircraft departed the area. The tactical problem was timing. Aircraft would detect a surfaced U-boat, approach for attack, and watch the submarine crash dive before weapons could be delivered effectively. Submarines needed only 30 to 45 seconds to submerge deep enough that depth charges became ineffective, creating attack windows so brief that pilots had one chance to position perfectly and deliver weapons accurately, and any hesitation or positioning error meant the submarine escaped. Survivors radioed warnings to other U-boats, and hunting aircraft returned empty-handed despite achieving detection. Coastal Command needed a weapon that could kill submarines instantly during the brief window between detection and crash dive. Something with the range of rockets, the lethality of depth charges, and the accuracy of gunfire. The requirement seemed impossible to satisfy until someone suggested mounting naval artillery on an aircraft, creating a concept so radical that most commanders dismissed it as impractical fantasy that violated fundamental principles of aircraft design. The weapon chosen was the Malines Class M, a 57mm automatic cannon developed from the 6-pounder anti-tank gun designed to destroy German panzers. The gun weighed 1,500 pounds with its 25-round autoloader, fired 3.3-pound armor-piercing or high-explosive shells at 2,900 feet per second, and generated recoil forces that would tear apart most aircraft structures, making the concept of mounting it on a fighter seem insane to engineers who understood that recoil would exceed the thrust of one engine and could snap the fuselage or throw aircraft into uncontrollable rolls. But making a naval gun fly required engineering miracles. De Havilland's engineers tackled the seemingly impossible challenge of mounting a naval gun on their fastest fighter. They removed the Mosquito's bomb bay and lower fuselage structure, creating space for the massive gun installation. The cannon was mounted on a reinforced cradle with shock absorbers that distributed recoil forces across multiple airframe attachment points, preventing concentration of stress that would crack wooden construction, and the installation angled slightly downward, 2 degrees, allowing pilots to fire while maintaining level flight, rather than diving dangerously low where German flak could reach them easily. The autoloader was a mechanical marvel. 25 shells fed automatically from a magazine, allowing sustained fire without manual reloading. The system achieved firing rates of 55 to 60 rounds per minute, nearly 1 shell per second, meaning a 3-second burst delivered devastating firepower that could penetrate a submarine's pressure hull, detonate internal systems, and kill the boat before crews could seal hatches and dive. But the autoloader added complexity that worried engineers about reliability in combat conditions. 4.303 Browning machine guns were retained in the nose for ranging and suppressing anti-aircraft fire. Pilots would fire the Brownings first, observe where rounds struck the water, then adjust aim before triggering the 57mm cannon. The combination proved essential because the Molines carried only 25 rounds, less than 30 seconds of sustained fire, meaning every shell had to count, and wasting ammunition on ranging shots would leave aircraft without enough firepower to guarantee kills. Detection technology was equally critical. The FB Mk XVIII carried ASV, air-to-surface vessel, Mk XV radar, a centimetric system that could detect surfaced submarines at 10+ miles in good conditions. The radar represented revolutionary technology compared to earlier metric wavelength systems that German submarines could detect and evade, and the centimetric radar's narrow beam meant U-boats received no warning of detection until aircraft were already positioning for attack, eliminating the early warning that had allowed submarines to crash, dive before aircraft arrived within weapon range. Coastal Command developed systematic hunting patterns over the Bay of Biscay. XVIII Mosquitoes would patrol assigned sectors at 1,000 to 2,000 feet altitude, radar operators scanning for surface contacts, while pilots maintained readiness for immediate attack. Once radar detected a contact, the Mosquito would descend to 50 to 100 feet above the waves, approaching at maximum speed, over 360 miles per hour, to minimize the time submarines had to react, and the low-altitude approach kept aircraft below most radar coverage until visual range, while speed meant submarines had perhaps 15 to 20 seconds from visual detection to impact. The weapon was ready, but could pilots actually use it in combat? XVIII attack doctrine was ruthlessly simple. Detect, approach at wave-top height, identify the target, open fire at 1,000 yards with Brownings for ranging, then unleash the 57mm cannon at 600 to 800 yards and maintain fire through 300 yards before breaking away. The entire attack sequence from visual acquisition to breakaway lasted 6 seconds. 6 seconds where submarine crews scrambled to man deck guns, where U-boat commanders made desperate decisions about fighting or diving, and where Mosquito pilots held steady despite instinct screaming to evade the tracers reaching toward them from German 20mm and 37mm deck weapons. The 57mm ammunition mixed 2 shell types strategically. Armor-piercing rounds would penetrate the pressure hull, creating catastrophic flooding that prevented diving. High-explosive rounds detonated on impact, killing exposed crew and destroying deck equipment. A typical attack would fire 15 to 20 rounds in a 3 to 4 second burst, with hits concentrated on the conning tower and forward pressure hull where penetration would flood control rooms and torpedo compartments, guaranteeing that even if submarines managed to submerge after attack, they'd sink rather than escape to repair facilities. Pilot skill determined success or failure. The gun's ballistics required precise aim point calculations. Firing at a submarine moving at 15 knots while the Mosquito traveled at 360+ miles per hour meant leading the target significantly. Pilots learned through practice to judge range, deflection, and dive angle instinctively, and the best XVIII crews could place shells into a submarine's pressure hull from 800 yards while flying at wave-top height in conditions where one momentary distraction or control input error would slam the aircraft into the ocean at speeds that would kill the crew instantly. The recoil was violent. Pilots reported the aircraft shuddering with each shell, the nose pitching slightly despite the shock absorption system. Maintaining aim during sustained fire required strength and concentration that left pilots exhausted after attack runs. And the physical demands meant crew selection favored experienced pilots who'd proven their ability to fly precisely under stress, rather than assigning the specialized tsetse variants to newly trained crews who lacked the muscle memory and instinct that kept aircraft stable during the violence of firing a naval gun at 360 miles per hour. The training was intensive but could never fully replicate combat conditions. Practice attacks against surface vessels and floating targets taught basic procedures, but nothing could prepare crews for the psychological impact of attacking a submarine that was shooting back. The first combat missions would reveal whether months of training and engineering innovation had created a viable weapon system, or just another expensive failure that looked impressive in trials, but couldn't deliver results when targets fought back with lethal determination. Theory was about to meet reality in the Bay of Biscay. The FB Mk XVIII entered operational service with Coastal Command's 248 Squadron in March 1944. The first combat patrols were tense. Theory and training couldn't predict how the weapon system would perform against targets that shot back. Crews understood they were flying an experimental aircraft carrying a gun that no one had previously fired in combat against submarines, and the first encounters would determine whether the tsetse concept was revolutionary or just another failed experiment. The first confirmed kill came on March 25, 1944. Flight Lieutenant John Turner detected a surfaced U-boat, executed a textbook attack run, and fired a sustained burst from the 57mm cannon. Armor-piercing rounds penetrated the pressure hull forward of the conning tower, and high-explosive shells detonated on the deck and conning tower structure, killing the anti-aircraft crew before they could return effective fire, and within seconds the U-boat was mortally wounded, flooding uncontrollably, unable to dive, and settling by the bow as surviving crew abandoned ship. Additional kills followed rapidly. By mid-1944, tsetse Mosquitoes had sunk or severely damaged multiple U-boats in the Bay of Biscay. The 57mm cannon proved devastatingly effective. Submarines that survived attacks by rockets and depth charges couldn't survive direct hits from armor-piercing shells that punched through pressure hulls, and even glancing hits from high-explosive rounds caused damage that forced submarines to abort patrols and return to base for repairs, removing them from Atlantic operations for weeks. But German U-boat command responded by dramatically increasing anti-aircraft armament on submarines. The standard 20mm deck gun was supplemented with additional 20mm guns, quad-mounted flak positions, and even 37mm cannon on some boats. The enhanced firepower created intense defensive fire that forced tsetse pilots to attack through walls of tracers, and several Mosquitoes were shot down or severely damaged during attack runs where German gunners maintained fire discipline despite incoming 57mm shells, proving that even overwhelming offensive firepower couldn't guarantee survival when targets shot back with desperation. By mid-1944, submarines bristled with anti-aircraft weapons manned by crews trained specifically for surface combat. Attack runs that had been merely tense became genuinely lethal as German 20mm and 37mm rounds tore through Mosquito wings and fuselages, and several tsetse aircraft were lost to defensive fire, forcing Coastal Command to employ tsetse Mosquitoes with fighter escorts that would suppress deck guns while the tsetse variant lined up its attack run. Success came at a price that kept rising. Only 27 FB Mk XVIII Mosquitoes were built, a tiny production run compared to other variants. The limited numbers reflected both the specialized role and the resource constraints of late-war production. Britain was prioritizing fighter-bomber variants for ground attacks supporting the invasion of Europe, and the anti-submarine role was becoming less critical as Allied naval dominance reduced U-boat effectiveness. But the XVIII's combat record demonstrated that airborne artillery could successfully engage surface naval targets with precision and lethality that rockets and bombs couldn't match. The strategic impact exceeded the raw numbers of U-boats sunk. The XVIII forced German submarines to operate more cautiously, reducing their time surfaced and limiting their operational effectiveness. U-boats that spent less time on the surface charging batteries had reduced patrol endurance and couldn't maintain position in convoy attack areas as effectively, and the psychological pressure of knowing that detection by XVIII-equipped aircraft meant probable death forced more conservative tactics that reduced overall submarine effectiveness even when XVIII aircraft weren't present in specific operational areas. The psychological impact on U-boat crews was devastating. Survivors reported that XVIII attacks were far more terrifying than depth charge runs because there was no defense. Once the Mosquito opened fire, penetration was guaranteed and survival was unlikely. German naval intelligence issued warnings about the new threat, instructing submarine commanders to crash dive immediately upon sighting twin-engine aircraft rather than manning deck guns to fight, essentially conceding that surface engagement with XVIII-equipped Mosquitoes was suicidal. Post-war analysis recognized the FB Mk XVIII as proof that specialized aircraft could carry weapons previously thought impossible to mount on airframes. The concept of airborne heavy cannon influenced Cold War ground attack aircraft development, with designs like the A-10 Warthog directly descended from the principle that the XVIII demonstrated, that aircraft could be built around guns large enough to destroy armored targets with direct fire, and that such weapons provided capabilities that missiles and bombs couldn't replicate. The XVIII also validated the Mosquito's fundamental design philosophy that wooden construction could handle missions that seemed to require all-metal airframes. Mounting a naval gun on a wooden aircraft seemed impossible, yet de Havilland's engineers proved that properly designed structures could absorb forces that theory suggested would be destructive, and the success demonstrated that innovative thinking combined with sound engineering could solve problems that conventional approaches considered impossible, establishing principles that influenced aircraft design for decades after the war ended. The Mosquito FB Mk XVIII XVIII proved that impossible engineering could create devastating combat effectiveness. Mounting a naval destroyer's gun on a wooden fighter created the most lethal anti-submarine aircraft of World War II, one that forced German U-boats to abandon surface operations or die in seconds from armor-piercing shells that turned pressure hulls into coffins. Watch the next video for more untold stories.